Alright, what I'm going to try and explain here is when we've got this graph of flux and the graph of voltage, it's all based on a coil rotating in a magnetic field. So this is our generator. Now, the question I've asked is when the flux here, it's negative through in this part, and it comes up to the horizontal axis and it changes direction. What I want to know is, why does the voltage not change? And I want to know an explanation in terms of practical terms. So this is what I'm going to try and explain with this setup here. So I've called this section 3 and this section 4. In section 3 you'll notice that I've put a little vertical coil. When the flux is maximum, that's when it's sort of edge on. You see that? That's when it's edge on in the magnetic field. And I've got the red side facing the south, north side facing the north. So the flux is going through this way. And we've called that a negative flux. So when the flux comes out of the red, we've called that a negative flux. It's rotating. We'll call it a clockwise rotation. So what we've got now, so that's why I've got these little dots here. They sort of represent just the dots of the flux coming through the red to the south. So at this stage, the last quarter of the graph and the flux is going from negative high to 0. So it's a decreasing negative flux. That's just what I've written here. You might not be able to see it in red. So it's a decreasing negative flux. So that's going to happen as we do that. As we do that, as that hole rotates, and we can see the green because we're looking down from above, the flux is still coming out of the red on the side. So it's definitely still a negative flux. It's just decreasing. And at the point where the graph goes through the top, that's when we've got a completely horizontal coil and therefore zero flux. But that's actually when we've got the highest voltage. Now you'll know that's probably because that's where the velocity is the greatest, but we're not going back to that at this stage. What we're saying is it starts here and it goes down to there. So it starts at maximum flux, negative flux coming out of the red, and it's going a quarter turn down to horizontal. That's what the flux is doing. Now we know that at that stage, and we want to work out which way is the current going to flow on this coil. So the flux is decreasing as we do that. It's negative and it's decreasing. So the coil's going to want to produce a voltage that's going to make it support that decreasing flux. So all we've got to do is think out which way is the current going to go around here to cause an increase in flux. Now we've said the flux comes through from north to south, so it comes out. So if I went like that with my right hand grip rule, current rule, that's not going to support it. That's going to go against that flux. So my right hand grip rule has to go that way, and then my fingers would come out through the red and support that collapsing flux. So based on that, I know the current is going this way. That's going to support the decreasing flux. That is what we've called a, if we look on this part of the graph, a negative voltage. But we know to get a current to do that, B would have to be positive and A would have to be negative for that current to flow like that. Now, the red has collapsed. We've got zero flux. Now what we've got is the flux coming out of the green from north to south. That's a positive flux in section 4. Okay. Now this time the flux is increasing. Now if it's increasing, the current that flows in this loop is going to want to go in a direction that's going to decrease that change. So if it's increasing, it's going to want to decrease it. So you've got to go with your right hand rule. How am I going to decrease the flux coming out of the green? Well, you need an opposite one to go back through the green. So I do my right hand grip rule. I want to go back through the green. So that means my current must go this way. Like that. And that means that B here must be positive and A must be negative. Let's see if the voltages change direction in this loop. So if we flick it over, The B's got a positive, the A's got a negative, B's got a positive, A's got a negative. Along this side, the current's flowing that way. This was after the green started to have the flux coming out of it. But before, when the red had the flux coming out of it, it was still going in the same direction. You see that? Tricky to think about, but that shows why the voltage here doesn't change even though the flux changed from negative to positive. It was two changes. There was a change in the direction of the flux, but there was also a change from decreasing to increasing. So those two changes meant that the voltage actually didn't change direction. We're done.